The Army is developing its weapons, technologies and platforms with a greater emphasis on being ready for great power, mechanized force-on-force war in order to maintain cross-the-board readiness and deter near-peer adversaries from unwanted aggression. While the service aims to be prepared for any conceivable contingency, to include counterinsurgency, counterterrorism and hybrid-type conflicts, the Army has been shifting its focus from 15 years of counterinsurgency war and pivoting its weapons development toward major power war. We are excellent at counterinsurgency, Lieutenant General Michael Williamson, former military deputy, Assistant Secretary of the Army, Acquisition, Logistics and Technology, told Scout Warrior in an exclusive interview last year. We're developing systems to be prepared for the full range of potential conflict. As a high-level leader for the Army's weapons, vehicle and platform developmental efforts, Williamson explained that some technologies are specifically being engineered with a mind toward positioning the service for the prospect of massive great power conflict. This would include combat with mechanized forces, armored vehicles, long-range precision weapons, helicopter air support and what's called a combined arms maneuver approach. Combined arms maneuver tactics use a variety of combat assets, such as artillery, infantry and armored vehicles such as tanks, in a synchronized, integrated fashion to overwhelm, confuse and destroy enemies. While the Army naturally does not expect or seek a particular conflict with near-peer nations like Russia and China, the service is indeed acutely aware of the rapid pace of their military modernization and aggressive activities. As a result of its experience and skill with counterinsurgency fighting in Iraq and Afghanistan, the Army's training, doctrine and weapons development is sharpening its focus on armored vehicles, long-range precision weapons and networking technologies to connect a force dispersed over a wide area of terrain. Another key aspect of the Army's future strategy is called wide area security, an approach grounded in the recognition that large-scale mechanized forces will likely need to operate and maneuver across much wider swaths of terrain as has been the case in recent years. Having a dispersed force, fortified with long-range sensors, armor protection, precision weapons and networking technologies, will strengthen the Army's offensive approach and make its forces a more difficult, less aggregated target for enemies. While the Army remains focused on being needed for counterinsurgency possibilities across the globe and hybrid-type wars involving groups of terrorists armed with conventional weapons and precision-guided missiles, the service is identifying, refining and integrated technologies with a specific mind to attacking enemies and protecting soldiers in major power war, Williamson explained. Major, great power war would likely present the need for massive air-ground coordination between drones, helicopters and ground vehicles, infantry and armored vehicle maneuver formations and long-range weapons and sensors. The idea is to be ready for enemies equipped with high-end, high-tech weapons such as long-range rocket, missile and air attack capabilities. As evidence of this approach, Williamson pointed to some of the attributes of the Army's new Joint Light Tactical Vehicle, or JLTV, and Armored Multi-Purpose Vehicle as platforms well engineered for large-scale mechanized warfare. The JLTV, for instance, is engineered with additional armor, speed, suspension, blast protection and ground clearance in order to withstand enemy fire, mines, IEDs and roadside bombs. These same protection technologies would also enable the vehicle to better withstand longer-range attacks from enemy armies far more capable than those encountered in Iraq and Afghanistan. The vehicle is being built to, among other things, replace a large portion of the Army's Humvee fleet. The JLTV represents the next generation of automotive technology in a number of key respects, such as the ability to design a light tactical, mobile vehicle with substantial protective ability to defend against a wide range of enemy attacks. The vehicle is designed from the ground up to be mobile and operate with a level of underbody protection equivalent to the original MRAP-TV, mine-resistant ambush-protected, all-terrain vehicle standards. Also, the vehicle is being designed with modular armor, so that when the armor is not needed we can take it off and bring the weight of the vehicle down to drive down the operating costs, Army officials have explained. The modular armor approach gives the vehicle an A kit and B kit option, allowing the vehicle to integrate heavier armor should the war threat require that. With a curb weight of roughly 14,000 pounds, the JLTV will provide protection comparable to the 25,000 pound MATV, thus combining the mobility and transportability of a light vehicle with MRAP-level protection. The vehicle can reach speeds greater than 70 mph. The vehicle, made by Oshkosh Defense, is also built with a system called TAC-4i independent suspension designed to increase off-road mobility in rigorous terrain, a scenario quite likely should there be a major war. The JLTV is equipped with next-generation sensors and communications technologies to better enhance soldiers' knowledge of a surrounding, fast-moving dynamic combat situation. TAC-4i can be described as variable ride height suspension, explained as the ability to raise and lower the suspension to meet certain mission requirements such as the need to raise the suspension in high-threat areas and lower the suspension so that the vehicles can be transported by maritime preposition force ships. Also, the JLTV will be able to sling load beneath the CH-53, C-130 or CH-47 under standard conditions. Sling loading the vehicle beneath a large helicopter would give the Army an ability to conduct what they called mounted maneuver, an effort to reposition forces quickly on the battlefield in rough terrain which cannot be traversed another way. Oshkosh, based in the Wisconsin city of the same name, last summer won a $6.7 billion Army contract to begin to produce about 17,000 of the light-duty JLTVs for the Army and Marine Corps beginning in the first quarter of fiscal 2016, which starts October 1st. The services plan to buy nearly 55,000 of the vehicles, including 49,100 for the Army and 5,500 for the Corps, to replace about a third of the Humvee fleets at an overall estimated cost of more than $30 billion, or about $559,000 per vehicle, according to Pentagon budget documents as cited in a report in military.com. When compared with earlier light tactical vehicle models such as the HMMWV, the JLTV is being engineered with a much stronger, 250 to 360 horsepower engine, Banks 6.6-liter diesel engine, and a 570 imp alternator able to generate up to 10 kilowatts of exportable power. In fact, due to the increase in need for onboard power, the vehicle includes the integration of a suite of C4I hits and networking technologies. The JLTV, which can be armed with weapons such as a grenade launcher or 50-caliber machine gun, has a central tire inflation system which is an on-the-fly system that can regulate tire pressure. The system can adjust tire pressure from higher pressures for higher speed conditions on flatter roads to much lower pressures in soft soil such as sand or mud, JLTV engineers explain. Also, instead of having a belt-driven alternator, the vehicles are built with an integrated generating system that is sandwiched between the engine and transmission in order to increase efficiency. The Army is also preparing to take delivery later this year of its new infantry carrier platform called the Armored Multi-Purpose Vehicle, or AMPV. Built by B Systems, the platform is intended to replace the Vietnam-era M113 infantry carrier. Several variants are planned, including a general-purpose vehicle, mortar carrier vehicle, mission command vehicle, medical evacuation vehicle and medical treatment vehicle. Overall, the Army plans to build roughly 3,000 AMPVs at a cost of $1 million to $1.7 million each. The platform is designed to transport troops, evacuate injured soldiers, escort logistical convoys and maneuver alongside larger vehicles such as Abrams tanks. The AMPV is designed with the speed to maneuver such that it can increase its chance of avoiding anti-tank guided missiles. An ATGM is the kind of conventional weapon the Army would be likely to face in a hybrid or great power engagement. The vehicle is also armored in order to reduce its vulnerability to long-range enemy weapons. The AMPV is a tracked vehicle built on the Bradley Infantry Fighting Vehicle chassis. It represents the Army's push to be prepared for the full range of conflict. For example, the Army is divesting some of its fleet of mine-resistant ambush-protected vehicles, or MRAPs, specifically engineered for an IED or roadside bomb environment. While being ready for that possibility is still important to the Army, and still very much a future possibility, the service does not need to keep its full inventory and is instead preparing for a wider range of possible wars. The general-purpose AMPV transports 2 crew members and 6 passengers. It is armed with a 50-calorie crew-served weapon and carry 1 injured soldier on a litter. The mortar variant uses a crew of 2 with 2 mortar technicians and an ability to fire 120mm rounds. The medical variant carries a crew of 3 and 6 walking passengers. The vehicle is also engineered with high-tech, software programmable radios designed to transmit IP packets of information across the force in real time. It has a vehicle intercom, driver's vision enhancer and radio and SATCOM communications network called Warfighter Information Network, Tactical. These technologies, along with a force tracking technology, Blue Force Tracker, displaying icons showing friendly and enemy force positions on a moving digital map, give the vehicle an ability to function as a node on a large-scale battlefield network. These kind of systems will allow the AMPV crew to conduct mission command functions on the move, share combat-relevant information in real time and use sensor to detect enemy fire at longer ranges. The AMPV also has a Duke V3 electronic jammer engineered to identify and jam the signal of an electronically detonated